Hello class. Today we're going to be talking about graphing systems of equations. Here are the 4 steps that you have to follow in order to solve a problem. So step 1, you want to write your equation in slope-intercept form. You always want it in this format so that you can find the slope and the y-intercept, because we are going to graph both equations using the same coordinate plane, right? So step 3 is find the coordinates of the points of intersection and write the ordered pair. Step 4 is check the coordinate algebraically by substituting in the ordered pair into each of the equations and seeing if the equations are balanced. So I'll explain all of that in this video. So first one, there are 3 types of solutions that you're going to get when you graph 2 equations. One of them is one solution. So this is when the graph of 2 lines whose intersection point is a single point. So let me explain to you what that might look like. Here's your coordinate plane, and let's say you have one equation. This is one of them. Okay, this is equation number 1. Oops. Equation number 1, I'm going to label it so you guys can see. And then I'm going to use another color. This is purple one. And let's say it looks something like that. It's equation 2. Alright, so the intersection, this is a solution. So you would figure out what the ordered pair would for that intersection is, and that is your solution. Infinite solutions, you have, again, your coordinate plane. And you have one equation. Let's say this is one of them that we graphed. We found the slope and the y-intercept, and that's what it looks like. It's a rough sketch. And then the other equation that you graph is literally this same equation. It's on top of the original one. So in this case, the graph of 2 lines that coincide, they are the same line. This is infinitely many solutions. So basically, you have all real numbers as your solution. Okay. In this one, you have an ordered pair, x and y, whatever that is. Okay. No solution is when the graph of 2 lines that are parallel to each other. We talked about this word in the previous unit. Parallel lines have the same slope, but they have different y-intercepts. So what that might look like, and you have your coordinate plane, and you graph finding your y-intercept. So you graph this one, and then the other equation is parallel to it, so it will never touch. So in this case, there is no solution. There is no solution to these graphs. You solved these problems algebraically in Unit 2 when you had infinitely many solutions, and you had an answer like 2 equals 2, right? We figured out that that was all real numbers. No solution was when we had a number equal another number that made no sense. So that was no solution. So now we're actually looking at them graphically. One solution is when x equals a number. Most of you guys kind of forget that, 0 is a solution. So that's just a review. Whenever you see x equals a number, that is a solution. All right, so let's look at some of these practice problems. Directions say, what is the solution for the system of equation represented below? Now, you have 2 linear equations that were graphed, and the intersection right here is your solution. So this has one solution. And that solution, I'm going to write down the ordered pair. That is -3, 3. As simple as that. Okay. For B, there's 2 equations, or 2 lines that intersect. That solution is 1, -4. So you have to be aware of what your coordinates are, and that's how you're going to be successful with these problems. Very simple, but there are ones that you have to graph yourself. Okay, so that's what we're going to be looking at in this problem. Using the graphing method, solve each system of equation. Now, the first one, we want to graph both of these. There's 2 different equations. So the first one, I want to find my slope. I know slope is always a number in front of my variable x. My y-intercept is a number behind the variable or the number that stands alone. So in this case, we use a blue. Actually, I'll do this one. Slope is negative 4/3. Your y-intercept is going to be 0, 3. Remember, the y-intercept is always your starting location. So, based on my slope, I have 0, 3. Plot that point. My slope is negative 4/3. Remember, we always move the negative to the numerator. So negative 4/3, and that means I'm going to go down 4, so that's a negative direction, and over to the right 3. So for my starting point, I'm going to go 1, 2, 3, 4, and to the right 1, 2, 3. So put me right here. Okay, I'm going to double check that. 1, 2, 3, 4, 1, 2, 3. Yeah. And if I were to continue the pattern, I can't. I'm running out of space, so I'm just going to draw my solid line here because it's an equation. Yeah, and that's it for that one. But now we have to look at the next one. My slope for the next one is 1. Actually, we use the same color, so I don't confuse you guys. Slope is 1 because the number in front of that x is a 1, and the y-intercept is negative 4. So let's write that down. Slope is negative 4. Oops. Negative 1, I'm sorry. And then the other one. Doing something here. Alright. 1/1. The y-intercept is 0, negative 4. So we're going to start from this location and use a different color. During this unit, or during this topic, you guys can definitely use different colors to graph. Have fun with that. So 0, negative 4 is on my graph, and I'm going to do the slope of 1/1, which is rise 1, right 1, rise 1, right 1. Okay. All the way to the end. Connect your lines. And hopefully you guys notice that this is the point of intersection. So that graph, or that ordered pair, is 3, negative 1. So that is your solution. Now, to check the problem to make sure that you've done it right, you are going to plug in this coordinate right here into each of these problems. So I'm going to plug in the x in this x and the y in this y. Same thing with both of them. So I'm going to pause this video to show you on this side what that might look like. So as you can tell from the right side, I checked my answers. I went back to the original problems and I substituted in the values to make sure that the equations balanced out. So when I put this coordinate point into the first equation, I got negative 1 equals negative 1, so that's what I wanted. For the second one, I did the exact same thing, a different formula, obviously, and I got negative 1 equals negative 1. So that's how you check that your answers are correct. Let's look at the next page. And now we are here, B. Now you're going to obviously change these equations into slope-intercept form because we cannot find the slope given the equation in standard form. So you guys know how to do this part. We've talked about this in class, so why don't you go ahead and try to do this. I'm going to subtract x from both sides. Divided by negative 4. So your equation is y equals positive 1/4 x plus 3. Okay, so that's my first one, and I'm going to do the exact same thing on the right side, but with obviously different numbers. This cancels out, so I get negative 4. Oops, let me move that over to the side. Negative 4y equals negative 5x plus 4. And if you want to pause this video so that you can have a chance to digest all of this, you can. Then you want to find your y-intercepts and your slope so that you can graph both of these. The slope of the first one is 1/4. Notice that I don't put x. A lot of you guys like to put x, but remember, slope does not include the variable. It's just a number in front. The y-intercept is 0, 3. For the next one, I have 5/4 as my slope, and my y-intercept is -1. So I'm going to use two different colors to show you this relationship here, and let's see what the solution might be. 0, 3. Got that first. My slope is 1/4, so that means I'm going to go up 1 and over to the right 4. And I have to do the exact same thing on the left side. Go down 1 from the original point and over to the left 4. 1, 2, 3, 4. Okay. Oops. And draw a straight line through the points. And then I'm going to take a different color and graph the second one from -1, 0, -1, and my slope is 5/4, so that means I have to go up 5 and over to the right 4. 1, 2, 3, 4, 5, 1, 2, 3, 4. Same thing going down, 1, 2, 3, 4. I can't do it because I don't have enough room, so then I'm just going to connect these 2 points. The solution is 4, 4. And so when I check, I will plug in 4 into the original equation. So for the first one, I'll say equation number 1. My y is 4, or so my x is 4, minus another 4. I'm just plugging in numbers into the original equation. And then equals -12. And then this will give me 4 minus -16, which gives me -12. I'm good to go. And the next one, equation number 2. I'm going to plug in 5 parentheses 4. Let's do that. Minus 4 equals 4. So this will give me 20 minus 16. 4 equals 4. Oops. 4 equals 4. Okay. See, if you want to pause this video and change them into slope-intercept form, you can go ahead and do that. I'm going to do that quickly for you guys. Alright, so I have converted all of these into slope-intercept form right here. Look, you can look at my work to see what I did, but now I'm going to graph them. You notice that they're both the same line, but we're just going to practice graphing these. And 3/1, oops, I forgot 3/1, 0, 2. So here, this is the example that we were talking about before. When you have coinciding lines, you'll have the same equation on top of each other. That's some equations, yeah. So here we go. I'm going to use another color, and this is the exact same one for the second equation. So when we have coinciding lines, or the lines that are the same, your solution is all real numbers. It has infinitely many solutions. Basically, all the points that are on this line can be possible solutions to this system. So when you're checking your work, you can pick any point that falls on that line, and it will be true. Okay, so you guys can check on your own to see if it's true or not. I'm not lying. But now I'm going to move on to D. If you want to pause this video and change and convert all of these into slope-intercept form, go ahead and do so. Okay, so I have converted each of my equations into slope-intercept form. You notice I've color-coded it so you can see my work. And I have my first equation, y equals 1/2 x plus 1. I don't have enough room to show you what the slope is, but I'm just going to highlight so that you guys can see. So for the first one, my slope is 1/2. My y-intercept is 0, 1, so I'm going to go ahead and start graphing that one. Start at 0, 1. My slope is 1/2, so up 1 over to the right 2. Up 1 over to the right. Continue the slope for the entire coordinate plane. Then I'm going to do my second one, and my slope for this one is going to be 1/2 as well, and my y-intercept is going to be 0, 4. So what is that going to look like? Oops, let's see. Oh, make this color. You want to use a different color. 0, 4, and up 1 to the right 2. Well, that's it for that side, and I just have to follow the different pattern to figure out the rest. And there you go. You have two lines that are parallel to each other. They have the same slope, just different y-intercept. So the solution for this one is no solution. It's an empty set. There's no possible answer that can be plugged in, or any ordered pair that can be plugged into both equations that will give us the same, the balance. Like, for example, the first one we were able to check because we put that ordered pair in here. For the last one, we can't check anything because we don't have any ordered pair that's intersecting, or they don't have anything in common. So then the last problem we have is the word problem here. It's just describing a fitness club, and we're going to be graphing that information. So a fitness club offers 2 yoga classes. There are currently 4 people regularly going to the morning class, and attendance is increasing at a rate of 2 people per month. So I'm going to highlight that because that is important. I need to find out the equation for this sentence. So this is my first system. The next sentence says there are currently 2 people regularly going to the evening class, and the attendance is increasing at a rate of 4 people per month. So that is another equation that I have to translate into an equation. When will the number of people in each class be the same? So we want to find the intersection point right here. Intersection of the 2 lines. Okay. Or the solution. So let's see. I'm going to use a blue that coincides with the first sentence. 4 people regularly going to, there are 4 people already going. So when we have our equation, 4 people is our starting point. Just like in graphing, our y-intercept is always our starting ordered pair. So we already have 4 people. Then there is an increase at a rate of 2 people per month. So my rate is, or my average rate of change, or my slope is 2. And I need to create this equation into slope-intercept form. So that's my first equation. My second one, there are currently 2 people regularly going to the evening class. So when I start my equation, my starting point is 2 people. And the rate, which also means slope, is 4 people per month. So X would represent the month, and yeah, so now we have to graph these solutions. I'll graph the first one. My slope is 2/1. My y-intercept, or my starting location, is 4. So let's look over here. Starting location is 4. And my slope is rise 2 over to the right 1, rise 2 over to the right 1. And let's see. The next one, actually, let me continue my line. I'm going to put arrows because you never know, it could be increased past 10 people. The next equation would start at 2 people. We go up 4. Oh, sorry, I need to write this slope down. You start at 2 people and you are increasing for a month. So up 4, 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1. So some of you have already seen this intersection right here. That is the solution of 1, 6. So the first week, or sorry, for the first month, there's going to be a total of 6 people, and that's where they both have the same amount of people in their classes. So if you want to, our X would be months, our Y would be people, number of people. Oops. There you go. This is your graph. Okay. You guys are going to be able to look at an equation, graph it, and then figure out the solution. So that's the overall goal for this topic. Let me know if you have any questions, and I'll see you guys in class. Bye.